morning, class. This is Mr. Walker here coming to you with our notes for circumference and area. We're finally starting a brand new unit. So, before we jump into the unit, we should probably talk about a couple of things that we know all circles are going to have. So, let's pull up a quick diagram of what we know about a circle and, all its different parts. So, I'm going to go ahead, let's grab us a quick little diagram. Okay, so here's a good one. So when we're taking a look at a circle, this is from our reading assignment that you guys are going to see later this week. A circle is a set of all points on a plane that are the same distance, equidistant from the center point. Now, on this, we have a couple of things that we know. The circumference, that is the distance around the circle. Eventually, we're going to get into chords. Those are line segments whose endpoints are on the circle. Then we have our diameter. That's another type of chord that passes through the center specifically. And then finally, the radius. That is a line segment that has one endpoint on the center and the other on the circle. Things to know about these two, we're going to be dealing with them quite a bit, is that the diameter is equal to 2 times the radius, and the radius is equal to half the diameter. So, without further ado, let's jump into some notes. All right, so talking about the circumference, just like we said earlier, it is the distance around our circle. Now, unlike what we do with perimeter on other polygons, there's no straight edges to measure, so we're going to have to look at a formula, which is necessary for this. So the idea of the circumference is like we're looking at the diameter and we're rolling it out until we get to the very end of this. So if we took the diameter and rolled it to match the distance all around this shape, it gets to about 3 Ds, 3 diameters, and zero point 0.4 of a diameter. This formula helps us to go through and know that the circumference is equal to pi times the diameter, or 2 pi r. Now pi here, that's what this 3.14 represents. It's a quick decimal. Let's go through and give you a few bits more when it comes to pi. It's represented by this nice handy little symbol here. It looks like a little table with a little squiggly line that you might see coming off of one end. It's a mathematical constant that represents the ratio of a circle's circumference to its diameter, aka C divided by D. So some things to remember about this. This is an irrational number. There's no exact numerical value. There's only a couple of approximations that we will use. Because we're using approximations, that's meaning that we're going to have to go through and round occasionally. So pay attention if you do have to round or if they want you to use this in terms of pi. If we are leaving it in terms of pi, that means that this symbol here is going to be left next to whatever else we can calculate. That's us leaving it in exact terms. We mostly do that because not everybody rounds correctly. Sometimes we can make a mistake. We don't always want that. For an approximate answer, we'll generally be using 3.14. Sometimes you could use the fraction version, which is 22 over 7, or you can go through and round it by looking at the decimal in your calculator. All right, let's take a look at the next definition we got here. The area of a circle is the space occupied by the circle. So all of this inside of here. Now, unlike our area for polygons like squares, triangles, and such, there's no base and there's no height, so we have to make a formula that uses pi, and it's going to have to use pi. That formula for our area of a circle is pi r squared, or pi times your radius to the second power. All right, those are two formulas that we got, so let's take a look at some examples. All right, so the examples you see on the left side here, these are ones from the We Do It on Our Notes paper, and these two on the right, these are from the I Do It on Your paper. So let's get down to business. All right, first off, you got to look at your circle here and know what they give you. So this part right here that they gave us for our first example, this is a line segment that comes from the center to the very edge of the circle. Whenever we see that, it's important for us to label that and know this is a radius. Now, if you're ever unsure where the center is usually some sort of dot like this, or it's very clearly, like in this case, going roughly halfway through the circle. Like you can kind of eyeball it. If it wasn't a line going through the center, they'd probably indicate it more with, more vocab. So in the case of this one, this is a line that goes, instead of it from the center, it's actually going from one end of the circle through the center to the other end. So that means this guy is actually a diameter. Now, once we know what we're dealing with, we can go through and figure out all the rest of the calculations as needed. So, for these first two, we're going to find the circumference and the area. We're going to leave our answer in terms of pi. So, first off, we're taking a look at our circumference formula. That is C is equal to 2 pi r. So, we got 2 times pi times r, which is 3.5. You can only multiply the 2 and the 3.5. We're leaving the pi as pi for right now. So that means 2 times 3.5 gives us a circumference of 7 pi. So we're only going to calculate the stuff that they absolutely want us to calculate. Anytime they say something like in terms of pi, that means that your answer has pi in it. Now for our second one, we got our area, that is pi r squared. So when we go through and fit our information in here, we got pi, that's going to stay pi. And instead of r squared, we got 3.5 squared. So 3.5 to the second power is what we're taking here. And then we put that next to pi, just like how we put this next to pi. This gives us 12.25 pi as our final answer for our area. So if they give you the radius, you can kind of just go through and jump in on it. If you are given something like the diameter, we do a little bit more so that we can figure out some stuff. So let's take a look at our first thing. First thing they want us to find is the circumference. You can either use 2 pi r, or in the case of what we have here, this is really us doing the diameter times pi. So we got pi times our diameter, which is 14. And then that means our final answer is 14 pi. Nice and easy. Now, for the area needs the radius. So the radius is equal to half of whatever your diameter is. So what's half of 14? Let's go through. We got 14 divided by 2. That gives us 7 for that radius. So now that we know this, because we know what this was, we can now jump into our formula. So our area is pi times the radius 7 to the second power. That gives us 7 times 7, which is 49 pi. Nice and easy for us. Now, for our next one, we're going to go through and work backwards with the information they gave us to find the radius for this first case and the diameter for this second case. So let's go through and figure this out. They give us here the circumference, which was 56.52. We need to go through and do some literal equations to solve backwards for our r. So we know what circumference is. It's really equal to 2 pi r. If both of these things equal c, that means I could substitute them to be equal to each other. So things to remember. You have two parts of this that we do know. They have, instead of 2 pi, this is 2, and then instead of 3, sorry, instead of pi, we got 3.14. And then we got r. So this is what that is. It's still equal to, 56.52. But it's important for us to know what information we go through and figure out. Now, these guys are all multiplying. The reverse of that would be us dividing. So if we divide these two sides by these two things, that gives us an answer of 9 as our radius. So just know what you need to go through to do. We would just go and divide by that 3.14 and that 2. If you feel more comfortable multiplying those out, you're welcome to. I just know that it is a new subject and I want to go through and show you it as succinctly as I can. All right, next one we're looking at the area. We're going to piece it up to figure out what the diameter is. So area is equal to pi r squared. So we know that this and this, they're both equal to the same thing. Now, we got to go through and solve some stuff. So when we go through and do this, let's fit the information that we can fit in so we can solve for r effectively. So we got 803.84 is equal to, now instead of pi, we're going to have 3.14. And we're looking for r. So we're going to have to undo this squared later. All right, first thing we got to do, we got to divide by 3.14 on both sides. When we divide both sides by 3.14, that gives me 256. Now, if we want r, we got to take the square root of both of these two sides. The square root of 256 gives me 16 for my radius. But are we done? Nah, they want the diameter. If you don't remember, the diameter is equal to 2 of our radiuses. So 2 times our radius here is 32. Nice and easy, people. All right, those are a couple of examples here. I want you to take a pause to yourself and try to figure out these next two. All right, hopefully you're back from our brief pause. Let's go through and look at our two equations that we are going to solve. It says for this first one, the circumference of the pizza is 10 pi inches. They want us to find the area and leave it in terms of pi. So we are given the circumference here. We know the circumference is 2 times pi r. So if the circumference was 10 pi, then half of 10 gives us our radius, which is 5. Now that we have our radius, we can now jump into the area formula. The area formula is pi r squared. So pi r squared gets me pi times 5 squared, which is 25 pi for our area. Nice. Now we have to make sure that we pay attention to the information they give us. We have to know which formula we're using, solve through that, and then go through and do the next one. Next one says Chandy is decorating for the school dance. She wants to wrap the clock in a floral garland and its diameter is 13. How much garland does she need? Use 3.14 pi to round to the nearest tenth. So this time she actually wants an actual thing. So we're going to be putting in 3.14 for pi. So if we want to figure out how much she needs to wrap around the clock, when we're talking about around this, we're talking about all this on the edge. So that is our circumference. So we're going to be calculating circumference here. Our circumference is equal to 2 times pi r, or it's equal to d pi. We are given the diameter, which is 13. So d pi, that's 13 pi. Now, We need to go through and calculate that. So this is about 40.8 inches at the end. All right, final one here. It gives us the center of a circle is located at -1, 5, and it passes through the point -1, -1, and they want us to find the circumference and area. So this is our center, and this is on the edge of it. That makes this nice little circle here. Now, if we want the radius for this, we know what the radius is. It's from the center to the edge, which makes this 6 for our radius. If that's the case, we can figure out our area and our circumference nice and easy. Circumference is equal to 2 pi r, which is 2 pi 6, and that is going to be 12 pi. Then for our next one, we got our area, which is pi r squared, which is pi times 6 squared, which is 36 pi, people. Thank you for watching. Nice 16 minutes of learning. I appreciate you. I hope you have a good day. See you.